this box has a frame in it because this one weighs a lot more. So I've unpackaged all the packaging and I've got all the electronics over in this corner. I've kept this space clean because this is where it's going to go, and all of the hardware here and the long parts of the frame here. So I'm going to open up the manual on my tablet and then we'll get building. So you might be wondering, if those shots were filmed 11 months ago, what on earth has happened in the last 11 months? And you might also be asking, Tom, I thought you ran a YouTube channel based mainly on 3D printed stuff. Why have you bought a massive CNC machine? Well, let's rewind about 3 years. Now, in the summer of 2015, I got introduced into drone racing, and I ended up designing my own drones. Basically, the drone racing frame, the carbon fibre components which would hold all the electronics together. Now, I actually turned this into a business whilst I was studying at university, where I would design, prototype, and then get the drones manufactured in China and then shipped over to England. Now, when I finished university, I aimed to go at this full time, so I built this workshop and I ordered this CNC machine. Now, this was about 11 months ago to a year from the point I actually ordered this CNC machine. And the idea was that it would help me prototype the drones a lot quicker, because the lead times ordering from China, as well as the high cost of ordering one-off parts, just wasn't feasible. So I did some research on CNC router machines, as well as asking a friend in the drone racing hobby who also had a CNC router machine, and he recommended this machine from a UK company who I won't mention the name because they don't deserve it, and this machine is an absolute nightmare, but I'll go into that in a second. I did consider designing my own machine, and I actually pretty much designed the whole CAD file to produce my own machine. I just had to find the right, lead screws and motors and everything, and also the controller. I had to learn a bit about the controller. But in the end, I was talked out of it from a friend, so I ended up buying this kit because I just didn't have the time to source all the parts whilst running the business. So in mid-July of last year, the parts for this kit arrived. They're about 2 weeks late from the scheduled delivery time, which was a bit annoying, but oh well, I wasn't in a huge amount of rush because I just got a few parts coming from China. So anyway, I got to work building this machine, and about 2 weeks in, I ran into numerous problems. Pretty much every nut and bolt that was supplied with this machine was either the wrong length, the wrong diameter, or had the wrong head, so it would collide with something else when the gantry moved or something like that. As well as the rails were the wrong width. The nuts that slide up and down the lead screws were the wrong diameter, and just everything was an absolute nightmare. So 3 months go by of me constantly emailing the guy that sold it to me, and him sending out new parts pretty much on a daily basis. New nuts and bolts being sent out, then I'd put that one in, move on with the build for about 20 minutes, find another issue, email him, get another part sent the next day. This went on for 3 months. Then I pretty much gave up with the machine, and it sat in this spot on my bench until about March this year. I just didn't want to touch it. Every time I tried to do a bit of work on it, I would just get really frustrated and angry and want to send an angry email to the guy that sold it to me. So in March this year, I decided that I finally wanted to get rid of this machine because every time I looked at it, I just couldn't stand it. So I decided it's better that if I get it off my bench, out of the shed, I can at least use this part of the bench, and it doesn't stress me out every time I look at it. So what I did is I emailed the guy and I said, I'm returning this CNC machine because I've just had enough of it. Sent it back to him, and then, believe it or not, last week it turned up in working condition, which is just absolutely unbelievable. Now, I say working condition, I don't know how this guy runs a CNC router business. For a start, every nut and bolt that I could find was loose. I've gone through, tightened them all up. There's quite a few bolts missing from the Z-axis, which I need to replace still. It's rigid enough to work, but it's not very good. The mounting for the controller, which controls all the stepper motors, is just, it's loose as anything because the bolts are too long. It is literally the worst built thing I've ever seen in my life. Now, I have spent the time to actually go through everything, so mechanically wise it's adequate to use right now. As I mentioned, I still need to get some more bolts to just make sure that the Z-axis is fully rigid, but everything else is fine. The end stops weren't actually reaching the limits, so the stepper motors and the lead screws would sort of hit the end stop before the switch would cut them out. So that could have ended in a disaster. I still need to fix up the water cooling, but I've only been experimenting with cutting wood so far. So just short periods of cutting wood, I haven't actually had any issues with it getting warm. But I still need to add that on and also mount a sort of nozzle for my vacuum cleaner to clean away the dust. Right now I'm just sort of doing it by hand. Now behind me you may be able to see this computer screen, and for you guys that do CNC routing you'll probably recognise this. This is just Mach 3 software. What it does is just runs a G-code to run the CNC machine. You guys that don't really know about CNC machines, I apologise if I'm using all these terminologies, but it's essentially a large 3D printer. When you 3D print something, you have a code on an SD card, plug it in, click print. It's the same on this, but instead of having a small sort of operated thing like on my Creality, I have to have a big PC here with a software. Now I'm not going to go through all the specific specs of all the electronics in this machine because a lot of you will probably get bored. So what I'm going to do is I'm going to try and cut something out. Now I've been cutting stuff out of wood just for testing, trying to run G-code, see if it cuts stuff okay, and I've actually been learning Fusion 360. Believe it or not, I don't use Fusion 360 on the majority of my projects. I've been using another CAD program which I learned at university, but Fusion 360 comes with a CAM software which basically you can program it to machine out certain parts. So instead of having to buy a separate program to write the G-code for the CNC machine, I can do it all in Fusion 360. So I think for this cut, I'm going to try an experiment with cutting plastic. I've bought some Perspex, which is essentially just the same as shed window plastic, and I'm going to try cut out a sign, which I can hang on my wall. Let's throw up a quick design in Fusion 360, export the G-code, and see if we can get this machine to work properly. So I've mocked up this slightly egotistical design where the text is engraved into the plastic. I then used the CAM portion of Fusion to specify and generate a toolpath, which also allowed me to run a simulation of what the router would do when I press go. The clear plastic was fixed to the chipboard bed with screws, and the bit was moved to the start position. Just a quick warning, if you have a CNC router and also use Fusion 360, you must be able to home your machine before this part or the machine may try to kill itself when you click go. Then it's time to start the spindle and click start. I was using some recommended values for the spindle RPM and the cutting rate, which were specified for acrylic. But as you can see here, the plastic is melting and sticking to the bit. Oh, and then a wire came loose on the Z-axis. After a few more trial and error cuts, the bit started to remove chips rather than blobs of melted plastic. So I set the camera in time-lapse mode and began the third attempt, which worked pretty well until the final outer cut snapped the bit. So that was a bit of a nightmare. I believe the issues I'm having is probably due to the plastic being quite, or having quite a low melting temperature. I didn't really know exactly what kind of plastic this is. It's labelled as clear polystyrene, but I couldn't find any information about other people that had CNC routed this kind of plastic. So I sort of just took people's values for their acrylic feeds and speeds and put that to the test. But it seemed like they were just way too high RPM and feed rate. So I believe that, well, acrylic probably has a higher melting temperature than this, because this was melting with the spindle at 2000 RPM, and on the websites that I was looking at, they're recommending 12,000 RPM for acrylic, which just seems a bit ridiculous if I'm honest. So if you enjoyed this video, please leave a thumbs up. I know it's not quite my usual project video. I spent most of the week trying to learn how to use a CNC machine and also relearn CAD software in Fusion 360, which I'm actually quite enjoying right now. So hopefully I can add more of my design processes into my videos. If you're new to my channel, please click subscribe, and if you have any suggestions for any future videos that I could use this CNC machine for, it would be greatly appreciated if you could leave a comment down below. A huge thanks to all of my patrons for supporting me. You guys make these weekly videos possible, and with your support I can now buy lots of router bits to cut lots of random projects out. Don't worry, I won't be leaving my 3D printers behind. These 3D printers will probably still be the main portion of my videos, but this will be used for producing more stronger structural parts for future projects. That being said, my project for next week is going to be solely made on the CNC router, well, also including some hand tools, but I won't be using my 3D printer. So stay tuned for that, and thanks once again for watching, and I'll see you next week. Goodbye.